All right. Hey there. Welcome to Project Wavy presentation two. This is Pedro, our lead front-end developer, uh, Jesse and Emma, um, our lead backend developers, and I'm Seth, data collector and analyst for project. So just reminders, our project overview, we're developing a website that is a framework for easily viewing local and regional climate trends. The goal is to imitate windy.com and the interface and workflow um, by easily being able to view climatological data and trends. And it's a project geared toward laymen, like everyday users and teachers, which will have some use for more professional researchers as well.
Okay, so right now I'm going to give a walkthrough of the progress that we have so far. So here in this page, this is what we have for our web page. So here we have the Florida map, which the researchers can use their main functionality to make assumptions about our data. So here right now we're using dumb data for these sections. Here the user can see the average temperature over a historical period. So here's going to be data over the last 30 years, but then later we plan to add also data for the user can select if you want to only see data for 10 years, 20 years, 30 years. So he can switch between different views and go to minimum temperature, maximum temperature, average precipitation. This data has been, we got this data from the backend. We're just kind of like selecting each coordinate. It's not accurate, but right now we just texted the collection. You can see there's a lot of interactivity. If the user selects here, you can see the metrics. You can also zoom out and check specific cities to see their difference.
For our next steps, we're going to continue to integrate backend data into the front-end interactive map, develop additional front-end components to enhance interactive map functionality, test and enhance front-end performance for improved user experience, improve the created API functionality to allow for efficient data retrieval into the interactive map, test the accuracy of the API compared to real-world data from other sources, automate the data retrieval from endpoints according to coordinate map. We will also investigate the possibility of implementing OpenAI API technology, start preparing project's final documentation, and explore the difficulty and steps to expand the map beyond Florida.
Okay, so for our task plan, so for the front-end task plan, first we want to test the layout. We want to ensure the map features are displayed correctly in various side screens and resolution. Also navigation, we want to ensure that can easily move between different sections and views of the map. Interactivity, we want to make sure that zooming, panning, and selecting different layers and overlays work accurately as we desired. Also data display, we want to ensure that historical data is displayed correctly when selected. So when the user clicks a point, it should display the right data. Browser compatibility, we also assume the user might be using different browsers such as Chrome, Firefox. We want to assure that it works for every browser. And also performance, we want to assure that our application loads fast, no matter the device or the browser the user is using.
For our backend testing, we will consist of data integrity to ensure that the data stored in the database matches the expected format, database performance to check the response times of the queries, and endpoint functionality to test each API endpoint to ensure it returns the expected results.
We also need to test the error handling. We need to check how the system handles bad requests or missing data. We need to test the security and to ensure that the endpoints are secure and can't be accessed without proper authorization. And we also need to make sure that the system, to test the system, load time and limits, because there is a lot of data. So we've got several issues, and one of them is difficulty finding or was finding appropriate data sets for this project, although I'm pretty sure we've found a good one. So we also have an experience with libraries and technologies leading to slower development. Our map also relies heavily on exact coordinates. So for the boundaries of each country, and that can cause issues with finding correct data for correct locations. And we also have issues with the leaflet interactive map library because it's limited to and hard to use when it comes to more advanced features such as interpolation or heat maps. And again, we're dealing with just a lot of data that can lead to performance issues.
So some of our individual responsibilities. So my goal as a front-end developer is to continue to add additional components to the front end. Also, I want to make sure that I do also a lot of testing to assure the data retrieval from the backend is effectively displaying in the front end, and also continue to enhance our map performance.
Yeah, I'm pivoting data sets to the ERA5 data set, which is part of the European weather model, because that provides data from 1950 to the present, hourly data at a wide variety of layers such as precipitation, wind direction, cloud coverage, that sort of thing. So I'll be pivoting and gathering all that data and putting it into our database. And I'm gonna also take the steps towards implementing a OpenAI API to train one of the GPT models with the data, so we can ask tailored questions about the data that users or researchers might want to find out about their local areas.
I'll be continuing to improve the server's application to connect to the database and create and enhance API endpoints and queries.
We're also going to test the backend's data retrieval and performance.
Okay, so this is a presentation. Thank you very much.